Alright, this is going to be our notes on food webs. We've been talking about ecosystems and the organisms found in them, such as producers and consumers. We've been talking about how energy is transferred. We're going to kind of look at that a little bit closer in these notes. Make sure you're annotating these. This will help you with the test that will take maybe the second day before we go for Christmas. And so let's get started on these. So we have a food web here, and I'm going to share one with you. Let me go to this link right here. Open this up. You can kind of get an example of one. Okay, here we go. Let's go down to one here. Right here. Okay, get this lined up. Okay, so you can see a little bit of an example of one here. Just down just a little bit. Okay, and here we have this food web. A lot of times people think of a food web and a food chain as the same thing, and they're not. Here in this food web, you can see several organisms at the bottom, and then as you move up through, there's more than one or two organisms sometimes. And here we see that at the bottom of the base of the food chain we have producers. These would be called primary producers. And then we have primary consumers, these copepods that then eat these primary producers. And then we have secondary consumers, and then we have tertiary, and so on. And then we have these apex guys at the top. And what I want you to notice though about this, and we'll go back to the notes, but many of these organisms eat multiple things. So like this herring can eat the fish larvae, zooplankton. They can eat copepods, which are also zooplankton. But they can also eat diatoms and conches and all those kind of things. So some organisms are omnivores, and some organisms also eat multiple things within an ecosystem. This is more like a food web. Okay? It shows all the relationships that exist. So if we go back, and if we get a definition of a food web, it's a method used to describe energy transfer in an ecosystem. And then we'll talk about this in a minute. Producers to consumers, and is it really inverted in a marine system? So this is a marine system. And I'll show you what I mean by inverted in a minute. So we'll go with that. And let's go back and look at this though. How energy transfer in an ecosystem. So if we go back to this, we see organisms here, but really what's getting transferred is the energy. So these bottom guys here are producers, and they're making energy by using the sun, the energy from the sun. They turn that light energy into chemical energy, carbon. They make carbon dioxide, or they use carbon dioxide as they do that, and they produce oxygen as a byproduct. And then these organisms, these conches and these copepods, they then eat these primary producers to get their energy, and so on as it moves up the chain. And that's really the transfer. So the energy goes from diatoms to conches to fish larvae to herring to tuna. Okay, so that's what it's talking about when it is talking about energy transfer. But then I also want you to think about the word that's inverted that I used. If we go back here. And maybe this means upside down, perhaps. Hope I used the right word, inverted. It's like it's turned upside down. Okay, and let's look at that. Maybe what I want you to see with that. If you usually at the base of a food chain is at the bottom, right? But if you think about the ocean in general, these organisms, diatoms, are at the top of the ocean. So they have to exist in that sunlight zone, or at least somewhat in the twilight zone, and then maybe go up into the sunlit zone, but they're at the top. And then these organisms, kind of similar, they're going to be at the top. But as you move up the food chain, think about where these organisms are. These sharks are lower in the pelagic zone, tuna are lower in the pelagic zone, and actually, even though these guys are at the bottom of the food chain, they're at the top of the ocean water. And these guys, although they're at the top of the food chain, they're at lower regions in the ocean, in the pelagic. So that's kind of what I mean by that. And so make sure you understand that. And then again, like I said, producers serve as the base, and they convert sunlight into, let me change that, sunlight into chemical energy, and that is photosynthesis, right? So photosynthesis is what they're doing. And you think about this though, also we look back at that food chain and we will in a minute. Think about consumers. They can eat pretty much anything. If they're eating plants, we call them herbivore. If they're eating insects, we call them an insectivore. It could also be considered a carnivore, right? As well, because they're eating insects. And then animals, because insects are really just animals. These are carnivores. And then everything would be an omnivore. Just eats whatever is available. Okay, and we have here's some others. A detritivore that eats decaying matter, and that would be like your bacteria and other organisms that get rid of decaying matter. And then if we also look at consumers, we have something called primary, secondary, and tertiary. And primary is just your first level. We're going to put that underneath them. Then second level, and then third. Then after that we might have apex, the top of the food chain. And we go back and look at our food chain. These are your primary producers, and the rest of these are just consumers that eat something else that produces the energy. And so this would be your primary consumer, secondary, tertiary, and we could even call these quaternary or apex. And these apex guys, if you remember, there's nothing much else that eats them. I think some dolphins and such, maybe some orcas, could give some of these sharks and certainly tuna a run for their money, for sure. But these guys have very few predators that are going to eat them. They're at the top of the food chain. So we might even be more proper to call a shark an apex, perhaps not a tuna. But these guys, squid and herring, could be eaten by a lot of other things. But that's your primary, this copepods and zooplankton. Secondary, these guys could be omnivores, both carnivores, and maybe they even also eat plants. Then these guys, this third level, they're probably, for the most part, going to be carnivores, and same with these apex guys as well. So we go back to here. And then we have these decomposers. We also call them detritivores. They eat something called detritus. Get rid of that capital E. So this is decaying organic matter. So something dies in the water, something's killed, whatever it is, plant. They help get rid of that in the ocean. And there's your decomposers. And if we look back at the food chain here, we could say really these decomposers may even be the ultimate apex, because they pretty much break everything down. So if the shark, even though it doesn't have a predator, one day it's going to die, and bacteria are going to break it down. And any of these organisms are going to get broken down by decomposers. So we could almost argue that the ultimate apex consumer are those decomposers. So if we come back. And then this rule of 10 as well, I wanted to show you that. And this is the idea that only 10% of available energy is passed on. Next level. And we often call these levels trophic levels. Let me show you that one more time. So these are primary producers, these are primary consumers, and they call these trophic levels, T-R-O-P-H-I-C. And each one of these is a trophic level, and as you go from these conches to these fish larvae, only 10% of their energy of the conches gets transferred to the fish larvae, and that's because it's used up. Like they have to do their own things as they're surviving to keep them alive, so that 90% of the energy that they get from the level below, they use up in their normal daily activities. So they have to eat to get the same amount of energy. Like, so for example, why this is important, So to get the same amount of energy this fish larvae does from this conch eating a diatom or whatever, it has to eat 10 of these because it only gets 10%. So in the end of this, the big thing to think about is usually at the bottom of a food chain, and I attached a video to kind of explain this, but and we may look at it in class, but the idea is that usually as you move up a food chain, now this roll isn't hard and fast actually, but it's a good thing to keep in mind that at the bottom of the food chain, because of this 10% roll, there's a lot more of these organisms. And as you go up in, there's less and less organisms. So here we see, you might think of like these fish larvae, there's a lot of them. But then you compare them to the number of sharks, there's not. Because this is a big animal, this big fish, right? And it needs to eat a lot of these organisms, so the competition and the availability of organisms isn't really there to support just as many sharks as conches or fish larvae or even herring. So as you move up, these organisms in the upper levels are going to get larger, but there's also going to be fewer of them because of this 10% roll. So if we go back to that, and then also remember, I think I brought this up at the beginning, that there's also multiple chains for each member. So in a food web, it shows everything. So a shark eats not just a herring, but it eats a tuna, and it eats perhaps other organisms as well. And if we go back to this food chain, food web one more time, so we have a tuna. The tuna eats a herring, he eats a squid, he might also eat an anchovy, and that looks like that's it. So, but we could do a food chain here though, and we could say a dinoflagellate gets eaten by a copepod, gets eaten by an anchovy, gets eaten by a squid, gets eaten by a tuna, gets eaten by a shark. So there's just flow from one organism or trophic level to the next. And the chain just shows the transfer of energy in that one direction. Food web though shows everything. So the shark eats a tuna, and then the tuna, but then we'll actually do a tuna. So tuna eats a herring, but he also eats a squid, and he also eats an anchovy. So we could actually have 3 food chains in here. We could say diatom, conch, fish larvae, herring, tuna, shark. We could also say though dinoflagellates, copepods, anchovy, squid, tuna, shark. We could also say diatoms, anchovy, tuna, shark. So we could do lots of different chains within this food web, but the food web just shows every single connection of energy that there is. Okay, and in the end, this is all driven by photosynthesis. So just keep these ideas in mind. I just wanted to introduce you again to some of these terms and go over them with you, see if you have any questions. Remember this idea of it's really in these food webs and these chains, it's an energy transfer, and oftentimes you'll see they have arrows in them. So these don't, but they show the direction of energy flow. In a food web, that's the correct way. So the arrow should be going to the diatom from the diatom to the conch to the fish larvae to the herring, and so on. And you might see them different ways, but that arrow shows movement of energy for the most part. And then if we go back, and also remember this idea of the numbers, and really maybe numbers isn't a perfect way to do it. So you could do number of organisms, how many diatoms are there? There's just an amazing amount, and there's not as many conches, and there's not going to be as many fish larvae, and so on. But also biomass. So biomass is the total, just organic material, the amount of that. And there's a lot more of this than there is of the next to primary producers of conches and copepods. And then of these organisms, there's a lot more of them, their biomass, than there is of the next ones moving up. And that's because you only get 10%, that 10% roll. So these anchovies have to eat 10 copepods to get the same amount of energy that a copepod when it just eats one dinoflagellate. And that just kind of drives this process. So there has to be more biomass as you could move down the food chain or the food web, and the most biomass is going to be at the bottom. So that's kind of your notes. I hope that works for you. Hope that helps you understand. Let me know if you have any questions about this, and make sure you understand all this. I've put videos on there if you need more. or you can see me as well, and that should work. Have a good day.